And let me make it a little bigger. Two 4 is called Solving Inequalities. A couple of things that we need to know when we are solving inequalities. We are still isolating the variable. So you're still going to be isolating the variable. And remember that in inequalities, it's very important, or at least it makes it easier for you if you get the variable on the left-hand side. All right? So I'm going to say to get the variable on the left-hand side. Did I? Oh, the other one. Gotcha, thank you. The other one, thank you. Being dyslexic, sometimes even looking at it, I don't see it. So, but thank you. I definitely want you guys to help me out on that. So, so you want to make sure you're getting the variable on the left-hand side. And also, when you are solving it out, if you ever multiply or divide by a negative, does anybody know what happens if you multiply or divide by a negative? Yep. You flip the sign, is right. And the last thing is, if you have a your less than or greater than sign, is when you are graphing, do you have an open or a closed circle? Is this open or closed? It's open. If I have something like less than or equal to or greater than or equal to, then it would be closed. So if it has this line underneath it, that is when you would have a closed line. Now, if you, like I said, if you keep your variable on the left-hand side, it's going to be nice because then you can just shade the way the arrow is pointing. If you keep your variable on the right-hand side, you really have to think it through to make sure you're shading in the right direction. All right? So that's what, when I say to keep it on the left-hand side, it helps you to know which way you are shading. All right? All right. Bless you. Examples. So the first examples we are going to do is we are going to determine if the given value is a solution to the inequality. All right, so what does that mean? If I gave you x plus 3 is less than 6, and my number that I want to know is 5, and that's what it's going to kind of look like. So we are going to determine if 5 is a solution to that. So if we are determining if 5 is a solution to that, what is that asking us to do? Plug in 5 for x and then see if this answer is smaller or less than 6. So if I plug in 5, I have 5 plus 3, and you guys already know that it's 8, but I'm going to just write it all down so if you need all of it, you can see it. So 8 is less than 6. Is that true or false? False. So it's false, so it is not a solution. It doesn't mean that there's no solution, but it does mean that it's not a solution. All right, you guys try this one. So we have 4x minus 1 is less than or equal to 3x plus 2. And the number I want to know if it's a solution is 3. So I want you guys to try that one. Alright, when you plugged it in, the first thing you have 3 times 4 gives me 12, minus 1 is less than or equal to 3 times 3 gives me 9 plus 2. So we have 11 is less than or equal to 11. So that is true. So what does that tell me? That 3 is a solution. Just so you know, that tells me so 3 is a solution. Yeah. Right. Now the next stuff that we are going to do is we are going to solve and graph. So we're going to do examples of solving and graphing. So we have 3. We have x plus 4 is greater than 7. Alright, so just like before, our first step then, class is, yeah, we're going to isolate the variable, but how are we doing that? What are we going to do? Subtracting 4s, right? So I have x is greater than your 3. On my graph, I'll just do it underneath it. On my graph, what you want to do is you always want to have that number. So I'm going to have my 3 here, and then I'm going to have 4 here and 2 there. You want to have some numbers on your graphs. Now on tonight's homework, there's no number, so you have to fill those in. You should always have one to the right and one to the left at least. So anyways, at 3, is that open or closed? Open. And it's open because there's no equal to. Then we simply, it's saying that it's greater than 3. So hopefully you all agree that we're shading this way. All right, number 4. Number 4, we have here negative 4x is less than 4/5. So we're gonna do one more so that I'm gonna actually do equal to, so because I had more, but I'm only gonna do one more. So negative 4x is less than or equal to 4/5. So how do we do this? What are we going to do when we are doing this? So you are going to be, you can divide by a negative 4, I do agree, but it's the same. See how this is already a fraction? So if we're not going to get rid of the fraction, what would we have to multiply? What's the same instead of dividing by your negative 4? What's that the same as? Multiplying by the reciprocal. So I'm going to multiply both sides by the negative 1/4. And the reason why I'm doing that is because this side has a fraction. So you can divide by your negative 4, but then you just have to remember it's same, change, flip when you do it. So I'm going to multiply by that negative 1/4. What happens, we have x on this side because that cancels out. what happens to the sign? It flips because I'm multiplying by a negative. So it flips. And we have here your 4's cancel to reduce, or you can multiply across, but the 4's are going to be reduced, and you get a negative 1/5. So on your number line, you have negative 1/5 is here. You have a number to the right would be your 0. A number over here would be like negative 2. It is opened or closed? Closed. And am I shading to the right or to the left? We're saying that x is greater than, you are shading to the right. Now if you, like I said, if you have the variable on the left hand side, you will be shading the way that your arrow is pointing. And that's why they say to put it to the left. All right. Questions? All right. What I want to do,